a minute to do them. Where is an AC method? Which part? Bottom right. So this is AC. Where are the ones that are only GCF? This one. And where else? There's one more. The top one is the square one and a GCF one. If you don't do GCF first, you have to do it at the end. So you could do GCF in the beginning or the end. The risk about leaving it till the end is you won't notice it because you're not looking for it anymore. That's the risk. So we all have the pros and cons. So take a minute and factor those and then see what cancels, and then we'll talk about it. Take a minute, do that. GCF and difference of squares on that top numerator. The GCF is 4. And when you factor that out, you're left with x squared minus 16. And then you do difference of squares on the x squared minus 16. So it becomes 4 times x minus 4, x plus 4 for this piece. Yeah, it has to be 2 perfect squares when you do that one. But I'm going to show you real fast what if you hadn't noticed the GCF? Because everything in the beginning is a perfect square. So if you had done that, you'd have 2x minus 8, 2x plus 8. But what would you have to notice here? That there's a 2 in each of those. So then what happens if you divide that out? You have this. And then the 2 times 2 is 4. And you see how you'd end up the same place I am. You just have to remember to do it, that's all. And then the bottom, the numerator here, 20x plus 20 has a 20 in common. And then over here on the right, the GCF in the numerator, what do they have? 7. So that leaves you 2x plus 3. And then you do AC on the bottom. It's the long method. You will have to do some grouping. Math ensues. Math continues. Math is finished. So, give me one. Give me one. X minus 4? I showed you the give me one video, right? Yeah. Okay, because otherwise that would have had no context and I would look more stupid than normal. Okay. What else? X plus 4. 2x plus 3. And then, all right, so here's what we have left. 4 times 7 is 28. They both have a 4. 7/5. You could have also simplified 4 over 20 right here to 1 over 5, and it would have given you the same thing. Who got 7 over 5ths? I mean 7 over 5 is what I meant. 7 over 5. You got 7 over 5ths? That's good, me too. All right, so that was a whole, if someone came in right now, they would think we're really smart. Doesn't this make us look really smart? Yeah, right? You should.
Knowledge is power.
Knowledge is power. Okay, so what we are doing today, let me start by saying this. What we've done this week is multiplied and divide rational expressions. This whole unit is just operations on rational expressions. That means add, subtract, multiply, divide. So we've multiplied and divided. Today we are adding and subtracting. Monday is a practice day. I have this fun fish game thing that's on the smart board. It's cute. And then Tuesday is your guess what? Quiz. That doesn't sound fun. I don't think that sounds fun. Okay. That sounds like something you had to memorize. What is that? Oh. Okay. So the lesson. We're adding and subtracting fractions, okay, with x's everywhere. Adding and subtracting fractions is easy when the denominators are the same. It's a whole other thing when they're different. I got it. I got you. Your objectives for the course only require us to do this when the denominators are the same. So since we don't have to do it with different denominators, we're not going to, because it's like when the denominators are different, it's this whole huge long problem. So we're just going to do the minimum requirements. Yeah. So we have other hard stuff to learn this unit too. So I'm trying to minimize like the hardness of it. So all right. So we're going to do this intro problem with just regular numbers, and then I'm going to use that as an example of how to do the one with the variables. We'll follow the same method. When you're adding plain old vanilla fractions with no variables anywhere, you keep the denominators the same if it's already the same. And then you add the top, right? 5 plus 4. So this becomes 9 over 6. And then we would divide the 3 out, right, and cancel it. But I'm going to show that to you in factored form so that it's more closely resembles what we're doing over here. Factoring it then, and then you cancel what they have in common, which is what? 3s. They have the 3s, and then it leaves you with 3 over 2. So keep this method in mind as we do this one with the ends in it. Do they have the same denominator, those fractions? Yes. So when we combine them, the denominator stays the same, just like it did over here with the 6. And then you combine the numerators. The first one is n squared minus. Okay. Yeah. Denominator. Well, now we have to factor. So just like we factored 9, 6 to 3, 3, and 3, 2. N minus 4. N plus 4, difference of squares on top. I'm excited about math. And what cancels here? N plus 4. One thing I want to caution you about is bad math. Y'all react like that every time. I'm going to do it more often because I love it. It's funny. You can't do 16 divided by 4 right here. Even though you really might be like, I need it to be 4. It's not, because those are being added and subtracted. You can't cancel stuff that's being added and subtracted. You can only cancel stuff that's being whatted. Yeah, what? You can only cancel stuff that's being multiplied. Very good. Thank you. All right. These are being added and subtracted, so they're not available for canceling. Okay. All right. So some example problems. I know it looks like a lot, but we're going to go really fast. On number 1, do they all have the same denominator? Yes. Are we adding the denominators? No. They stay the same. We're adding the what? Numerators. So it's 2 plus 1 plus 7. What is 2 plus 1 plus 7? Can I simplify the 10 over 3? No, so I'm done. Look. You do number 2. Raise your hand when you're done with number 2. All right, thank you. Thank you, thank you, thank you. Raise your hand if I did this problem correctly and you got the same thing I did. 3 over n. Excellent.
Oh, snap.
You didn't simplify? Number 3 is just like the second example. Who got n plus 3 for number 3? All right, excellent. On number 4, they kind of start changing a little bit. So let's come back together as a group for number 4. They don't start changing too much, but. Oh.
Hello, people watching the video.
All right. On number 4, do they have the same denominator already? And are we adding the denominator? No, we're just doing the math on the top, right? So I have 7t plus 2 plus 2t minus 11. Combine like terms. What combines there? 9t minus 9 over. Yes. Mario, are you done with that one? Because I'm dying to slide this thing. Okay. Yes. GCF first. You can, okay. I want to say yes, you can GCF the whole problem, but students aren't generally good at that. Here's what I mean by that. I mean, if you're going to GCF the whole thing at one time, you're dividing on a number that comes out of every single term. This one, and this one. There is a number like that. It's 3, okay? I don't recommend that because students don't generally have a lot of success remembering to do it to every single thing. They'll just do it to parts of it, and then they'll mess it all up. So here's what I recommend in my professional opinion that you do. GCF the top, what do they have in common? 9. And then when you divide 9 out of the second term, what are you left with? 1, right? It's not nothing, so a lot of times people will just leave it as a blank, but it's really a minus 1. So we have this. So I GCF the top, the bottom. You could factor 9 and 9. I'm sorry, 9 into 3 and 3, and 6 into 3 and 2, but either way you'd be canceling out a what there? A 3. So nothing about the t's cancel, and that's fine. They don't have to cancel. So I'm left with 3 times t minus 1 over 2t. How come I can't cancel these 2 t's right here? Good. One's being subtracted. The parentheses don't really have, it's not the parentheses, it's that the t on top is with a subtraction, so it's not free for canceling. Okay. So then on number 5, someone last period said, well, don't the bottoms just cancel because they're the same and you're subtracting it? It's in the bottom. We're not doing math on the bottom, right? Okay. Sorry, that was a student from before. So then we're doing the math on the top. So now we got this. Agreed? Okay. Thank you. What method is for the numerator? GCF. And what math is on the bottom? Okay, take a moment and do that. Y'all are terrible. Y'all are so mean to each other. Okay.
Have you also posted it if they don't think that's like Hey, have you seen the accounts where they just keep reposting so they make it big? Yeah. That's the formulas.
I don't think anyone's ever felt so sure.
Yeah, I'll get straight to
Already ask me a question and then get no response.
Focus. When you factored, did you get this? Okay.
Well, I do now.
Yes, the t minus 2. T over, how many of you changed the T's to X's?
I did, yeah.
I have zero problem with that. I don't care.
Because I,
One thing though to keep in mind, like let's say next year if you go to school, you go to college and you're taking an online, if you have a class where you have to enter your answers online, just remember, computers are way pickier about what they accept for answers than I am. If it's looking for T and you switched it to X and you're like trying to put it in X and you're like, I know I did it right. Why isn't it giving me credit? Yeah, you have to be careful. No. You have to multiply in order to do that. That's right. All right, so let's talk about the two on the back real quickly. Do you want to do these two, or do you want me to just give you a worksheet? Oh, that's good. Well, here's the thing. All these problems are on the worksheet I'm about to give you. So you've already done some of the work.